Hi everyone, this video is just meant to be a review of class from Monday, January 27th. In one of my classes we didn't finish this example, and in the other it was a little bit hurried, so I wanted you guys to see this example. If you've already gotten this example, then there's another example on page 230 that has one similar to this. So the first step to find all of the possible rational roots is to look at the possibilities for what are the factors of -6 and what are the factors for this coefficient, which is 1. Now this one's going to be our P, this is going to be our Q. So the possibilities of what can go into -6 are plus and minus 1, plus and minus 2, plus or minus 3, and plus or minus 6. The numbers that can go evenly into Q, well, the only number that can go evenly into 1 is positive and -1 itself. So now if we take this P and Q, our possible roots are formed by P, sorry, I had a little bit of a moment there, formed by P over Q. Well, since Q is just 1, it's always going to be 1 over 1, 2 over 1, 3 over 1, and 6 over 1. So if you notice, it's just the same list that we have here. Now, if another possibility for Q was like 2, then we would have to do 1 over 2, 2 over 2, 3 over 2, 6 over 2, but we don't have that. So these are the only possible rational roots. Now, keep in mind, these are not the only possible roots. A rational root is something that can be written as a fraction. So this doesn't include things like square roots. This doesn't include imaginary roots. But when we go ahead and do our synthetic division, these are the numbers that we're going to see in synthetic division. So one way to figure out what to do synthetic division on is to guess. And that's where we talked about just plug in different numbers and see what equals 0. Because if you get 0, that means it's a root. Another way is if you graph this on your graphing calculator. So if you graph this function, x cubed plus 6x squared minus 13x minus 6 in your graphing calculator, this is just another technique you guys can use to shortcut the process a little. You can actually see visually that x equals 2 is an x-intercept. And if you want to take the moment to pause this video and actually check that, you should be able to see that. If you don't see that, then you want to make sure your window is correct. You can also use the second calc and go to 0. If you remember, x-intercept is the same thing as a 0 of the function. And we also said that it's the same thing as a root. So we can actually look at the graph to see our rational root. Say you didn't do that though. Eventually, you would guess by plugging in 2, you would get 2 cubed plus 6 times 2 squared minus 13 times 2 minus 6. This is 8 plus 24 minus 26 minus 6. And this is 32 minus 32, which is 0, which means that 2 is a root, and x minus 2 is a factor. Now, you don't have to write this all the time, but I just want to emphasize that this is what it means. So now that you know one of those roots, you can actually go ahead and do synthetic division. And we're going to use that number that we get for the root. So 2 is going to go in the box. We're going to put the coefficients from the polynomial, which are 1, 6, -13, and -6. Carry the 1 down. Multiply the box times the 1. Add that next column. Multiply the box times that answer that you just got. Add the next column. multiply the box times the number you just got, and that's the last column. You should get 0 in the end as your remainder because that's what we saw here. Well, now this function we have to translate into a quadratic. This is x squared plus 8x plus 3. So now we're going to have this function f of x equals the answer we just got from the synthetic division times the root we got previously, x minus 2. And we want to get this quadratic into a place where we can see the roots like this. Now, one of those techniques is factoring, but another technique, this can't be factored. So the only way to find the root here is to use the quadratic formula. I just want to copy that down again. Apologize, I have the sniffles here. And so to use the quadratic formula on this part, we're going to do negative b plus or minus the square root of b squared minus 4 times a, well a is 1, times c, all over 2a. So this ends up being negative 8 plus or minus the square root of 64 minus 12, which is 52, all over 2. Now at this point you may get a hunch, well maybe I can simplify this, but we can't just cross these out because there's not a 2 out from here. So you're going to start looking to see, is there a perfect square that goes in 52? And I can rewrite 52 as 4 times 13. 4 goes into 52 13 times. So now, if I think about it this way, what's the square root of 4? Well, the square root of 4 is 2, so I can pull that out of the square root. But I can't take the square root of 13, so that has to stay inside. So now we can rewrite this entire thing as negative 8 plus or minus 2 root 13 over 2. Well, now hopefully you notice that there's a 2 that goes here, can cancel. A 2 can come out of the 8, and we're left with 4. And so this is negative 4 plus or minus root 13 over 1. So we don't have to write that over 1. So now let's write all of our roots. Well, from this term, don't forget about this term that we got from synthetic division. We know 2 is a root. We also know that negative 4 plus root 13 is a root. We also know that negative 4 minus root 13 is a root. Notice how 2 is rational. It is the only rational root. These are not rational because they have square roots in them. So we see 2 in our list, but we don't see any root stuff. That's okay. It's okay to get roots that are not rational. They just won't be on our list of possible rational roots. Another hint that I want to offer you guys, besides the fact that you can use a graph and you can use your quadratic formula, is that sometimes you won't actually get a rational, you'll get a rational root, but it won't be an integer. So on number 14 and on number 15, just a heads up, there are no roots that are numbers like 1, 2, 3, like integers. If that happens, so just to give you a hint, on number 15, this was 6x to the 4th plus 35x cubed minus x squared minus 7x minus 1. Last night, over the weekend, you should have seen that the possible rational roots are plus and minus 1, plus and minus 1/2, plus and minus 1/3 plus and minus 1/6. And sorry, that is all. These are the possible rational roots. You will find out that if you plug in 1 and -1, it doesn't work. You don't get 0. So you may be like, what do I do now? I encourage you to graph it. And if you graph it, you should see for this problem that x equals 1/2 is a root. What you can do in that case is that you can take that and do synthetic division on it. I won't tell you what the other root is, but there are lots of methods you could do. You could plug in all of these and see which ones work. You could graph it to see which ones you see as an x-intercept, and those are kind of the two methods that you can use. So number 14 is similar to that. A hint for number 27. I won't tell you exactly how to read this word problem, but it's not that hard. There's a lot of words, but the math is really not that bad. What I want you guys to think about is if I gave you a problem like this, how would you be able to find the roots? Hopefully you guys see right away that this is not equal to 0. So you would have to set this up as x squared minus 6x minus 2 equals 0. And then from here, try to find the roots. And you guys are welcome to use a graph to do that. You're welcome to use other means. So 27 is a little bit more involved than this, but it's very similar in where you're going to have something equal to a number, and you're going to have to set it equal to 0 and solve. And that's it. Again, this video, hopefully if you watched it, was not mandatory, but was meant to help you with your homework.